So we are going to do three-dimensional plotting in R. So let's clear the environment. Um, so we need to have three axes, the X, the Y, and the Z. So let's define a sequence from negative 2 pi to 2 pi and a length of 256. And y is another sequence from negative 2 pi to 2 pi. It has to be the same length as x, so 256. Now, z is a function, just like, maximum. We need to define a function, so let us define a function. I am going to call that function as fun3d. And fun3d is a function that is going to take two variables as inputs, x and y, respectively, and it is going to return x times cosine x plus y times sine y. So what we're going to do for 3D plotting here is use the basic perspective plot that is in R. Now there are advanced packages that offer us better 3D visualization, but we will do that later after we take care of perspective plots in the base package in R. So to compute the z values, we can't simply evaluate the function. Rather, we have to use a function called outer. So outer x values, y values, and the function that we just created, which is fun3d. So let's run and see if everything is in place. Everything works. So let's go back to the environment, and you can see that the x values are here and the corresponding y values are over there. The z values, and you have a matrix, and naturally we should expect a matrix because we are defining a function in two variables, x and y. Our objective is to visualize this as a surface in 3 dimensions. So the function here is persp, as in perspective, and the first argument is x, the second is y, and the third is z. And let's go ahead and evaluate it. It is the most basic case, so we are going to run that. And that is the plot that we end up getting. But you can see that we are unable to move this or turn it around. So that is one of the disadvantages of using the persp function that comes in the base package. There are other functions which we will get into later on, which offers us more flexibility in terms of rotating and looking at the surface from different angles. So could we add titles to this plot? We absolutely can. So persp x, y, and z. Like always, we could say main, which is title. So let's say perspective plot or 3D plot of Fun 3D. We can specify an X label. We'll say X values. We can specify a Y label, Y values, and we could specify a label for the vertical axis, which is the Z label, and I'll call that Fun 3D values. And let's see what we get. So there is our plot, and so it gives us the labels, X values, Fun 3D values, and the title, which is the perspective plot of Fun 3D. There are other things that we can do here. So in Maxima, we have the elevation and azimuth. In R, we could use the same thing, which would change the viewing angle. So So it can easily be done by using two arguments, which is theta and phi. So theta is the elevation and phi is the azimuth or the co-latitude. So I'm going to set theta as 45 and phi at let's do 90. So we are looking at it from the top, and that is what we get. And naturally, it doesn't give us a pretty picture, so perhaps we should change the viewing angle to something else. So let's change theta and make that, or let's change phi to 45. So now you could see that it is producing a 3D plot at a different angle. So by changing the values of theta and phi, you could get different perspective plots. This requires a lot of tinkering. I would rather go for an advanced function like persp 3D that comes in a different package, and we can just rotate it using the external graphic device and try to get a nicer picture easily. So now we can go for some coloring schemes here. So I am going to copy and maybe just for fun I'm going to change that to 60 and going to specify color equals spring green. doesn't help us much. Let's change the angle 30. So there is green, we just aren't able to see it clearly. We can use a scaling option. Um, let's say if we could use a scale and make this prettier, or we could zoom it here, and if we zoom it here, we could see that nice green color. It shows up naturally, and by default, scale is true. Now, if I set scale is equal to false, you can see that the box is kind of elongated compared to what we had previously, which is not. So the default setting is actually better, leaving it as is as true. So going to keep scale as true, and I'm going to choose shade. Let's point full. Let's erase this. So that didn't do much in this particular example. So let's go for a higher value and see what happens. Let's do 0.7. So it seems to have no effect here in this particular example. Um, but in some cases you would get a different um, coloring option, in the sense you get a different illumination when you look at for instance a shadow that you can observe under light. So you could get that effect. It's merely a 3D effect, and you could get that 3D effect with shade, but we're just not able to see it in this particular example. So as we move on, by default, the box is on. So box is a logical value, and box is true by default. So we are going to turn off box. Do box equals false, and let's run that. And the box is gone. The disadvantage here is if the box is gone, the axis would also be gone. So just like how we control ticks in a regular 2D plot, we can actually use ticks in a 3D perspective plot also. So we can use the axes uh, argument which controls the axis. Let's set it. Well, we need to have the box if we want to have axis. So we'll make the box true and set axis equals true. And we can also specify the number of ticks on the axis. So let me specify n ticks to be equal to um, 10. So as you can see that it did not produce the axes labels as we expected. Perhaps we could try to introduce another uh, argument which could give us the axes. So let's see. I believe it is tick type. Let's try simple. Uh-oh. Interesting. I would expect to see the axis, but it is not showing up. So just like we can add lines and points to a plot, we could add lines and um, um, points to a 3D plot. Um, we just have to, directly put it on top of the existing perspective plot. So how would we go about doing this? So what we can do here, since our x and y values are between negative 2 pi and pi, I am going to define a variable. Let's see, I'll call it adding lines and points. Well, maybe I'll save this with perspective 3D and just stick with colors for now. Um, so let's go back to the color function, but this time we are going to use a palette instead. There are multiple options. I believe the persp 3D function in the persp or the plot 3D package has preset gradients and palette functions, but here we may have to create our own. So let's quickly search for this color ramp palette. So the color ramp palette is going to create a gradient between a set of values or color values. So I am going to call it my color, and my color is color ramp palette, and I am going to say purple and turquoise. And I am going to try and use this um, in my perspective plot directly. Oh, let's run this first. So So my dot color is a function, and that is going to create a bunch of RGB values. But we have to generate colors corresponding to um, the length that we have for Z. So you can see that this function is defined with one variable, and that variable is n. So now what I'm going to do is I'm going to use this function, because when we define color ramp palette, it is going to return a function with one argument, and that argument is n, and there is that function. So let us do this in the console. We'll do my dot color of 10, and we get a bunch of colors. Those are HTML color codes. Since the length of Z is 256, I believe, in our case, so we are going to go for 256, and those are the colors that we generated. So we will call it my colors, and that would be my dot color of 256. Now select that, and we will paste it over here. That is our plotting function, and we are going to use that in a bit. Now what we have to do is to create a facet. So we'll leave that plot function as is, and let's create the facet. So those are our Z values, and let's create a facet. I'll call it Z FCT, and that would be, we need a couple more variables here. So we know how to find the dimension of Z. Z is a matrix, and it is 256. So nrow dot Z would be the dim of Z, and pick the first dimension. Ncol dot Z would be dim of Z, pick the second dimension, and now we could create the facet or set facet. but I'll explain in a bit as to what this does. So when we do minus 1 and minus 1 and save it to W with the matrix Z, the dimension of W now becomes 255. In other words, we are simply dropping the first row and the first column. So here nrow.z and ncall.z would have 256 as saved values. Let's run that. 256 and call.z is also 256. So the second part right there is going to remove the last column and the first row, and that is going to remove the last row and the first column, and that is going to remove the last row and the last column. We're just doing this to create a facet center, which we can use it in the colors. So once we have that, what we're going to do is we're going to make use of a function called cut. So you could always look at cut help, and it specifies what cut does. It cuts the range of x into intervals. So we already have x, which is right here that we created, and if I said cut x into 20 intervals, those are the intervals that it automatically created for us. So those are the intervals that we cut, and what we're going to do is we are going to take the facet values that we have generated, and we are going to facet coloring. So facet color, cut facet, and I'm going to specify 256. So let's see if all of this works. It did. So what did it do? It simply took the Z values that we had in that facet matrix, and it split it into 256 intervals, and we saved those intervals into the variable facet.color. Now we're simply going to go to a color argument here and use the colors that we generated, my colors, and put in facet.color. So that's what we have, and it may not be quite clear if the colors did get applied. So if we zoom this a bit, you can see that the colors here correspond to what I suggested in my initial setting, where I said the color is between purple and turquoise, and that's exactly what we have here, purple up to turquoise. So key things to note about The base package, persp, or the perspective plot, is that it requires a lot of extra tweaking, like we did over here, and the one we did over there. Um, so we have to create our own color ramp palette. We can change it if we want from purple to red or to spring green, and we have to take those colors and create faceting and cut it, take values in the matrix for Z and put it in specific intervals that are defined over here so that we can assign colors to each of those intervals, and that's exactly what we did up there. So it requires a lot of extra work when you try to use the base persp function, but the persp 3D function in the plot 3D package has additional features that the base package doesn't offer. We will do that later.